Discuss today something that has been initiated in January, February of this year, when the Commission adopted an environmental compliance assurance action plan. Now, these are big words, very big words. Compliance assurance. Geospatial intelligence is another topic in this session. Now, to put it fairly simple, compliance assurance, what does it actually mean to us, to you? I assume that everybody is driving a car, right? Or a bicycle, whatsoever. Now, what we do have are certain rules, right? You cannot speed in areas where, for example, you can only drive 30 kilometers an hour. So, you are traveling with your car, and you see a piece of information. There's a board, and it says 30 kilometers an hour. But you don't know really what it means. Okay, so it says 30 kilometers an hour, so I assume something must happen. But you don't know the law. Actually, fact is, if you don't know, you would totally ignore this number, right? There's a law behind it that tells you if you break the speed barrier, you risk to be fined, right? Now, this is what compliance assurance is about. In the first place, right, it's you need to uphold the law. We are talking about geospatial intelligence. Now, what's the difference between geospatial information and intelligence in that context? The information is you can drive here maximum 30 kilometers an hour, but you don't have a clue about the consequences, right? And these consequences are provided by the law. If you break the law, you are going to be fined. Now, that's you as a duty holder. That's your role. You are the duty holder. You need to respect the law. Now, there's a second category of users in compliance assurance. You're not going to like them, or you will like them. I personally like them because they protect me, right, against people speeding when my kids cross the car. These are the inspectors. In this particular case, it could be the police, the inspectors. This is the second big group in our user category of compliance assurance. These are the people that know the law. They know you cannot drive faster than this. Now, why is the law important? Because it provides us not just with the information, but it provides us with the entire context. And therefore, the information becomes intelligence. It's being put together with a certain framework of law that you need to respect. Now, if worse comes to worse, and you have been breaking the law and speeding several times, at a certain moment, you will have to go to court. And those inspectors, they will have a record of you, because you've broken the law 5, 6 times. They are going to build a case against you, a case which is based on evidence. What's part of the evidence? First of all, where did the infraction happen, right? How many times did you break the law, etc. That's our third category of users in compliance assurance. Call them the enforcers. It's the judges, it's the prosecutors, and so on. Now, in terms of infractions, again, the example of speed, if you break the law once and the police officer is standing there with his radar gun. The radar gun is a piece of technology that will tell him how fast you were driving, and it will also tell you where you were driving. That's geospatial information collected with a sensor. Very important. It happens once. This is what we call the category of the smoking gun. I will give you immediately an example in the field of environment. But it's also possible that people have been monitoring throughout the years over that stretch of road how many accidents have happened there. Although we can only drive 30 kilometers an hour, there were accidents, several accidents, a lot of material damage, maybe even people got hurt. It's a systemic problem over a longer period of time. This is also a compliance issue. Now let's take a little mental jump. Let's now go to environment. Let's think about a protected site. Suddenly, in a protected site, concerned citizens, an NGO, informs those that have to uphold the law that apparently somebody is breaking the law in that forest. There are logging trees where they should not. How do you know that you cannot log trees? Because logging trees is part of normal forest management, right? Now, every protected area, which is part of the Natura 2000 network, must have a management plan. Within that management plan, it says this area, for example, are pristine forests. They should not be touched on. The other area, yes, here you can log and do normal sustainable forest management. These are grasslands. You can cut them. Those you need to maintain, right? It's the management plan which provide the context, right? The information is there is grassland, and it's of high ecological value. There are trees, and they are of high ecological value. But that's not intelligence, that's information. When it becomes intelligence is when, in that particular case, there is a threat, there is a law. And that's very important when we discuss this application case for Inspire. I can give you hundreds of thousands of different cases like that. For example, myself, in my younger days, I worked on illegal oil spill detection aboard of ships. We were using, at the time, satellites equipped with radar instruments, and we could actually see the oil spill. It was like an elongated spot on the water. You saw the trace of the ship, and probably the oil spill came from that ship. It was connected by this wake on the radar image, right? That's information. There is a law, the law of the seas, that you should not pollute. Then the inspectors came in, and we worked with the Norwegians, for example, in the beginning. Is this evidence, this image? No. You cannot prove that this dark area and the line and the ship are actually connected, right? You need to have more proof. So what did the Norwegians do? They sent a boat or a helicopter, whatever. They took samples of the oil spill. Then they boarded the ship. They took samples of the oil that was left in the ship. They brought that together to build the case against those that were breaking the law. The law, again, provides the framework. Now, today's session is not about all the different types of data. It's not about all the different application domains. However, in our action plan on environmental compliance assurance, in our action on geospatial intelligence, we are going to look at several areas, be it on air quality, be it on the marine domain, but we have one priority at the moment in the plan, and this is compliance assurance in rural areas. Now, I don't know how many of you have read the description of this particular session that was put online. It presents the concept of geospatial intelligence for the first time, actually, at least in environmental law and action plans, that you will find such a term. And when I first came up with that term, I said, Hugo, this is for, I don't know, for spies or for the military. I said, no. Essentially, it's for dealing with threats, and the intelligence is provided through the context in the law. So we decided to go for this concept of geospatial intelligence. As I said, today is focusing on the rural areas. Now, I mentioned before the radar gun of the policeman, right? This is a measurement instrument. There are other measurement instruments, like I told you about the forest. In that particular case, we used Copernicus satellites, then we used other satellites, we used airborne data, we used observations on the ground, and we brought that all together. Geospatial intelligence is actually a gathering, a combined discipline of different sorts of intelligence that you can bring. In the introduction, and I could ask you actually, how many types of intelligence gathering do you know, which is part or could be part of GEOINT? Anybody has an idea of these different disciplines which contribute? Nobody? Okay. I already mentioned images, right? Remote sensing observations, imagery intelligence. I told you the story about the NGO that took pictures of the trees that were felled. They took plots, they had GPS coordinates, GNSS coordinates, and they send them up. These are humans equipped with a sensor, right? The GPS signal is what we call signal intelligence. Goes into the equation. Imagery. signals, location. And the people, that's called human intelligence. People as observers, they are saying, people are speeding systematically in my street. They're very important. We bring them in the equation, right? And then, of course, people are posting these things. They are twittering about it. They're putting it on Facebook. Open source. Again, open source is one of the gathering disciplines for the type of intelligence that we need. Now, what ties all these things together? Location, first of all. We need to bring these things together on location. If the speeding happens, we need to know where is the road network, right? It's about people breaking into houses. We need to know where the buildings are. We need to have the map of the protected sites. We need to know in the protected sites where all the different ecosystems. We need to have the management plan. These things are brought together generally in the geographical information system. And the challenge now is out of these different types of intelligence that we have to, first of all, most importantly, prevent the problem from happening. We need to inform the duty holders that this board of 30 kilometers an hour means you should not drive faster. And when you do, these are the consequences. In our action plan, a very large part of the activities are meant to inform duty holders about their duties, what they can do and what they cannot do. The second category of users are these inspectors. They do not have this radar gun. They do not have access to the imagery. They do not have training to make sense out of it all with the GIS. And we want to build up a capacity and to equip them so that they can deal with the problem at the local scale, at the regional scale, even at the global scale. In the Copernicus program, we are going to have a satellite that is going to measure CO2 emissions. Why do we have that? Well, because there are an international law that tells us we need to curtail CO2 emissions. And then finally, of course, we need to bring it together for some of my colleagues in my own directorate who are working on the law. They need to bring up the evidence. So those people need to be informed. The presentations that we are going to have here today are not necessarily about geospatial intelligence in that context, but they are going to inform us what, with certain tools, such as the Copernicus, the Sentinels, other measurements, and so on, what kind of information we can collect to then put it in the context of the law, right, and turn it into intelligence. If we don't know what is technically feasible to be done, then we have nothing.
Thank you, Hugo, and also thanks for this very nice introduction that provide the framework of this session. It also will help me to do my presentation, which is in fact is a joint presentation. It's a joint presentation with many colleagues. Actually, it has to be presented by my colleague Guido Lemon, but unfortunately he had to be on another meeting elsewhere, so I was available to provide it. But it is a presentation that shows what we have done in GRC in collaboration with DG Agri for the new. Okay. Thanks. For the new approach in relation to the control of the more than 40 billion euro of subsidies that are given to the European farmers annually. And certainly this can be put a certain extent within the framework of this session, because it's indeed about checking the compliance of the farmers with respect of the rules of the common agriculture policy and the distribution of the payments, both direct and rural development. So before jumping, and I try to be brief, just I'll try to explain you why we did it and what is the difference, using the example with the police cameras of Hugo. So, okay. Yeah. So, every year, a number of farms in each member state of EU is selected for controls on the spot in order to verify that the system for administration and control that manage the payments to the farmers are working properly. And this is done either through inspection on the field or using remote sensing. Due to the limitations of the technologies so far, I mean, by the end of the last decade, and the limited availability of very high resolution satellite data, it was not possible to do this 100% territory-wide. Therefore, there were a number of sampled farms that were checked annually. And even though there are just a limited number, the work was tremendous, and the administrative burden associated both from the side of the administration and from the side of the farmer were really significant. What the Commission found out, and what the Commission proposed based on the availability of new technologies. And here we speak mostly about sentinels. Now, with the quality of the geospatial information, with the performance of the administrative systems, with the availability of very high resolution geospatial information at member state level, with the temporal resolution of the Copernicus satellite, we will be able to do this control territory-wide on 100% of the application. So, if currently we had the chance to control the streets of a town with just a couple of policemen standing on the corners that most of the drivers know there will be, now we have the opportunity to install, let's say, this is the, I will try to do this analogy. We were able to install cameras on every street. So we will, in a way, we could ensure that every driver will be monitored one way or another, so he will not, let's say, escape the check, and this logically will introduce better behavior. And this is happen also, this we think will happen with the farmers, because once they know that they're not, that, okay, it is not that they might be part of a sample and they might have a chance 1 out of 5 years or 1 out of 10 years to be in the control sample. Now they know that every year there will be control. And this will somehow, we expect, will impact, will influence their behavior. So, but of course, the introduction of this monitoring was not only about boosting and make the behavior of the farmer better. It was firstly made because of simplification. We need to simplify how the system of control works, because it was really too much burdensome and probably not so efficient. And this is the short-term gain. The long-term gain will be that with all this abundant Earth observation information territory-wide, we will be able to use the system to monitor the performance of the common agriculture policy with respect to the targets that it meets, more particularly in the environment and the climate domains. Of course, we know that with the sentinels, we have some limitation. The limitation of the technology, we have a very good temporal resolution, but the spatial resolution is somehow limited up to 10 meter pixel size. And for sure, we know that probably the area will not be able to check it directly on the sentinel. With the sampled approach that used so far, we used very high resolution satellite images, which had sufficient spatial resolution to ensure that we can measure also the area. But in this case, we don't need to do it because we have other systems in the IACS, in the Integrated Administrative and Control System, that will ensure it. And this will be the land parcel identification system and the geospatial aid application. This is the second one is the digital entry, the entry point of all information that farmer provide for his annual declaration, which is then cross-checked with the reference information on the area, on the relevant land cover that is registered in the LPS. So the area component will be ensured by the IACS. So what we will monitor will be the farmer activity, because the farmer, in order to receive payment, he needs to activate this payment, or let's say to declare it on land that is agricultural, but also he needs to conduct some activities. And some of these activities are also environment and climate related. And this monitoring, what we would like to design is to make it almost fully automated. And therefore, there are numerous concepts that were introduced. One of the most important is the concept of the markers. The marker is, let's say, the observation that will reveal a certain status of the land phenomenon or change of the status. Okay, marker can be, it's similar like the speed limit or the radar signal for the cars. Okay, just a couple of slides to show the abundant amount of information we have so far. With optical Sentinel-2, we have worldwide coverage with between 5 and 10 days revisit time. For Europe, it will be 5 days revisit time. With the Sentinel-1, the other one, it's again worldwide, with some limitations in some areas with respect to the revisit time, but for sure over Europe, we ensure 6 days revisit time, and this is cloud-free. So this is a data flow in unprecedented frequency, even higher than the one required for the precision farming. Okay, this is just a nice picture of one of the country. I assume it's Czech Republic, or maybe Hungary. Okay, it's Balaton Lake, yeah, sorry. Of course, we all have seen this, this type of nice mosaics. The important thing is that this mosaic is created probably 10 times faster than any previous mosaic, due to the really high, temporal frequency. So I won't go into detail about the markers, but this is the key concept of all monitoring, because we would like to make this system as much as automated as possible. And there are different type of parameters and characteristics that we will try to monitor. Here, there are some examples of markers. Examples related to the change of the land phenomenon in time, in relation to the crop practice. Special markers related to some management practice that change the okay, that changed the spatial heterogeneity and others. Just an example of what a marker can be. So here we have the different type of signals during time. This is derived from the Sentinel-1, the coherence and the back scattering. What we're looking for is specific drops, or let's say changes, or specific peaks of the signal that can be related to specific farming activity. And there are already some pilot studies that proves that this concept works quite correctly. Some other examples of similar temporal profile from the optical data. Of course, not always we need to associate this behavior to what we expect from the farmer applications. Any change of phenomenon, or let's say specific markers that indicate some non-compliances, like for example burning of stubbles, could be used as well. But in any case, here we speak about enormous amount of data that needs to be processed. And for sure, we will have to use the most sophisticated and advanced methods like machine learning and artificial intelligence. Some pilots are already ongoing. Of course, member states will have to set up and rely on extensive computing infrastructure. We hope that with the Copernicus DS and in support of Agri and DigiGrow, we will be able to provide some solution to the member states. And for sure, we need to work here together. It's not just the Commission telling member states. It's we, together with the member states, had to design this solution based on let's say, multi-actor approach. Just another example how we use the machine learning results. Actually, we use it. This is an example of Denmark to derive from the declared parcels the specific temporal profiles of the different crops that are specific for different region, and using some methods and concepts that we designed in GRC. It's the so-called Tegan concept together with the land cover meta language, which is a part of the inspired data specification of land cover. We are using it to train and to parameterize the marker that they can be tailored for each specific country and each specific region. At the end, we need to be aware that this monitoring will not serve only the purpose of the compliance of the control. Together with the LPS and in the geospatial aid application, in the future IX data sharing network, the monitoring will provide quite essential information that is missing from the IX registers for the future reporting for environment and climate. So just to conclude, now the CAP monitoring is really at the high of the political agenda. We have already some member states that this year are doing pilots, and by the end of this year might introduce it operationally for the next year. Actually, we have one member state that already does it a given region. And while it will be essential as a compliance assurance term, in longer term, the monitoring will provide the framework at one of the framework, at least at EU level, with respect to the monitoring of the environment and climate commitments, which will be somehow embedded in the future CAP 2020, which is yet to be decided and finalized. Just at the end, to confirm what Hugo said, this was not set to be a system to penalize. It was set to be a system to prevent. And we hope we will be able to achieve this objective. Thank you.
Okay. So my question is, I'm Franco Fontanot from Sears, France, and I ask this question about the use of very high resolution ortho images as GEOI or world view in the CAP controls.
Yeah. So first of all, in short term, many member states will continue probably to use the current on-the-spot checks framework, and we use the very high resolution images to control these 5 or 10% of farms, because not all member states can be ready at once to jump towards monitoring. Yes, in longer term, we expect that the member state will go to monitoring, but this doesn't mean that that the VHS satellite that will not be used, because they are currently used for checking the quality of the LPS, and this will stay, because in order to run monitoring, member states had to prove that the quality of the LPS is guaranteed every year. Also, there will be other, let's say, quality assurance systems related to the monitoring in particular, and to the geospatial aid application, where such very high resolution data will be used. But maybe it will be at lesser extent than now.
Okay, thank you.
Okay, thanks, Pavel. So this was an excellent example of something that is already in place since 20 years and has been improving. Like Pavel said, this is to prevent infractions from happening. But what we have learned here is, of course, we have the context, we have the subsidy, we have cross-compliance with environmental legislation. But what we see is that thanks to the improvement of the radar gun, right, the observation capacity that we have now in place, the reliability, and that's very important in a legal case, of the information that we extract is becoming much higher. And that's very important in our compliance assurance work. It's not like environmental monitoring where we can say, okay, it goes up, it goes down. No, this has to be precise and correct, because it affects the livelihood of people. It can have dear consequences for the farmer or for the state as well. So this is an important aspect of the type of work and the type of instruments that we need. They need to be reliable, right? And what we have also learned here is that you need to bring together different types of data. You've seen land parcel information, sometimes information from the cadastre, declarations from the farmers. All these administrative systems, they need to be hooked up, some registers and so on. And it's with this in mind that I have the pleasure to introduce the next speaker.
Well, the truth is that I couldn't imagine for a better introduction to what we have been doing so far. So I think this is why everything happens, because everything happens at the end for a reason. So having such a great introduction into what we are doing saved us a lot of time. Good afternoon, everyone. My name is Machi, and I'm happy to be here with you today to share some of the results we have from a great project called RECAP. RECAP was funded under Horizon 2020 2.5 years ago, but the idea came into our minds more than 4 years ago. I'm not a part of this technical team discussing accuracies and everything. I'm just an agronomist. But being an agronomist, we understood very early that when you're working with farmers, they see their community and the community of paying agents administration, organization, EU, to be so far away. So we try to find a way to make them understand that this gap between them can actually be bridged by technology. And how? Let me tell you a few things about cross-compliance and how difficult it is for farmers to follow and paying agencies to do it efficiently and transparent. Now, as we heard, farmers' activity have an impact on environment, as of course all of the activities that humans have. Now, when it comes to the farmers, when they get subsidies, they need to follow specific rules, and this is under cross-compliance and greening. But cross-compliance is like driving without knowing where you will find the signs, as Hugo said. It's a big legislation that it's very complex. It's very difficult for farmers to even find, read, understand, and then implement on the field. It requires from them to read and understand, in some cases, more than 150 specific measures that they have to follow. And that leads to high costs for the paying agencies, time-consuming procedures, and a lot of complexity. Now, what RECAP can offer to these challenges? We thought that living in the era of satellites, getting those data that are out there, and so far paying agencies are using for LPIS systems only, could make sense for cross-compliance as well, not only for crop classification, as we will see later. So we take the satellite data, along with data that are produced by farmers on the field, in order to help them understand and to raise compliance. The issue here is not how many more fines we can pay or how many more farmers will lose subsidies, but how we can raise compliance of the farmers. So what we do, we break down this very complex legislation into practical, everyday steps that the farmer has to follow. So if you cultivate cotton in Greece, then you get to see on your RECAP platform only the rules that apply to your situation, to your parcels. And on the other hand, the public authorities can have a tool that will help them be more transparent and more efficient, because up to now, cross-compliance was checked only at 1% of the farmers, and every year, with a random sample. That meant that most farmers really neglected to follow cross-compliance, don't even know about cross-compliance, to be honest, and there was no way for them to contact the paying agencies to understand when they were coming, to prove what they were doing on the field throughout the year. We have been working for more than 6 months with our users. And that is because at the beginning, when we were thinking about this platform, we thought that one size could fit all. Let's build a platform for everyone in Europe, for everyone in the world. Well, that does not apply to our case. Because when we started working with paying agencies, with farmers and consultants, we understood that throughout Europe, you have different levels of maturity for the paying agencies, different systems in place, different political ideas and vision for the agricultural sector in its country. When you are working with farmers, then you have different systems also and consultants. So we understood that we had to work really close to co-produce, co-develop, and produce at the end a platform that's going to be monitored by our farmers and be accepted by our paying agencies. Now, RECAP is offered as an open concept. We understood as a company very early in the beginning of this project that there is no point to keep it in-house. We will not gain anything out of it. So our business plan does not go with just bringing a solution and keeping it into our home. We offer it as an open solution for the whole agricultural ecosystem to build on top of this. Now, the idea and the technologies used is, of course, remote sensing. We have a remote sensing tool that is used to identify crop type, of course, to extract useful features, and more, as you will see later, along with our spatial tool that is helping to, at the end, to visualize all the information and all the layers that we are using from the paying agencies, and we end up at the business intelligence tool. I don't know if that, Hugo, is relevant to what you were discussing earlier, but I think it fits very well. You get the environment, you get the legislation, and at the end, you need the technologies to bring all that together. Now, along with that, and one of the innovations of this platform is the SDK tool we built, because as I told you, we are looking for an open discussion with the ecosystem out there. We give them tools to build add-ons on top of the applications that we have already built. And working with our users for these years, we have understood that we needed to integrate, to be able to integrate parts of the services, or the whole service as it is, in their existing systems that they are already working with. And all of this is offered through a web and mobile application mainly for the inspectors and the farmers, and the web application for the paying agencies. Now, just a few slides, you can see everything tomorrow in more details. All of the partners will be here at 2 o'clock in the same room, where we are going to present recap and the results. So you can, we will be more than happy to welcome you here, where you can see in more details what we built. Now you see here that when it's the farmer's application, when a farmer is actually entering the platform, then they get do's and don'ts. What is it that you need to do for specific measures, how you should do it. Upload all necessary documents that you need to upload, discuss with your paying agency or your consultant, have an open procedure for the whole cross compliance scheme. And, sorry, but the time is pressuring, so just a quick overview of the spatial tool, the remote sensing tool that we have. We believe that farmers, consultants, and paying agency can be offered with a tool that's going to make their work more efficient, more transparent, and more open. But on top of that, they're going to save time and money. And the whole community, the whole European community under CAP will have actually a tool that will help farmers comply and improve the environment they are working for. Now, until now, just a quick overview, more than 700 farmers have already tested this platform in Europe, more than 300 consultants, and 133 inspections have taken place so far on the spot checks using the RECAP platform. For us, this is just the beginning. We tested this with the Greek paying agency and the Lithuanian paying agency. We tested that with semi-public agricultural service in Spain, the consultants part, and in UK with a big company of agricultural consultants offering these kind of services to their farmers. And in Serbia, we did a pivot because as we were expecting to use RECAP there as a tool that would help farmers be more familiar with the CAP policy in general, in order for them to be compliant when the time comes, we understood that one of the big issues in Serbia was organic farming. It's a scheme, environmental scheme, that they need to follow in order to export their products. So we transferred this whole workflow system legislation or remote sensing component into an application for the consultants and farmers for organic farming in Serbia. And regarding accuracy, Pavel has already discussed this, but we have managed in countries where we had a lot of data, not a lot of clouds, the parcel levels were good, to have a high accuracy, which is super important for paying agencies, as you already know. In Lithuania, we are still working on it, getting more data, because we have the situation with the clouds and everything. But we are working to improve that as well. But you can hear, as I told you, more tomorrow. Now, most of our users are talking about time, saving money, using it, paying for it. It's an important tool. One of the inspectors in the paying agency told me once that if you didn't bring this into life, we should have invented it. It's really needed for our everyday work. Especially in the case of Greeks, we have more than 85% of the Greek agriculture under this scheme checked, which means that we can go to a 100%, as Pavel was talking about, monitoring cross-compliance scheme and CAP in general. So tomorrow at 2 o'clock, you can hear more about RECAP. Thank you for giving us the time and the floor to share with you the results of these projects.
Thank you, thank you. Thank you, Machi. I didn't interrupt you because there will be time for questions in the second part of this session eventually, and certainly tomorrow. I didn't want to interrupt you because this work that has been going on there is so spot on the issues that we are trying to work. Support to the duty holders, support to the inspector, the paying agency, a powerful administrative tool which facilitates the life and increases trust in everything we do in Europe. So it's a beautiful presentation. You have seen a box there. It talks about Copernicus and satellites. Before, Pavel was mentioning the same. There are different peoples around Europe which are working and improving these algorithms, bringing these different sources of information together, using Copernicus as an opportunity. And with that, I would like to introduce the next speaker, which from Horizon 2020 project, right? It's called SENSAGRI, or Sense4Agri, I think it is. Developing prototypes for new Copernicus services for agriculture. So again, by pooling all this expertise together, we're going to get a much better understanding about what is feasible, what is needed, and so on. So please join me here. Don't stay there, otherwise it's not going to work.
Okay, good afternoon. Thank you very much. And thank you very much, especially to Hugo, to his excellent introduction to the subject, which I was a bit far away before coming here. So yes, this presentation will deal with this one of these pieces, which in this case is the generation of this information for agriculture. The results that I'm going to present are part of an ongoing project, Horizon 2020 project called SENSAGRI, Sentinel Synergy for Agriculture, which, as you see, could you see here, it involves several research centers and technological agricultural centers throughout different European countries. Basically, the goals of the project are to develop new prototypes for future Copernicus core services, mainly in the pan-European land component of Copernicus. So this is the target, and especially dedicated to agricultural applications, but not only. Basically, what we propose and we are developing and validating are a new service for surface soil moisture, a service for green and brown leaf area index, which is a proxy for vegetation biomass, and a seasonal crop time mapping service. And linked to this, I will detail later, several proof of concept services for agricultural monitoring products. All of these based mainly in the combination and the synergy of Sentinel-1 radar with Sentinel-2 optical data. Within this project, we not only propose several prototypes, but we are doing a strong effort for validating them with field data. And it's essential to be in contact with especially with the Copernicus and trusted entities and the main users in the agricultural sector to be sure that what we're doing it's indeed useful. So basically, SENSAGRI, the position of SENSAGRI in this context, all the groups benefit from several previous experiences in related projects, and some of them are very well linked with the policymakers and also with some examples of market application. All the developments in this project are driven by the need for new services in Copernicus, and basically this summarizes the different the different products we are offering. But I will enter into details. Okay, just to be So basically, we propose these 3 prototypes, which are all based on previous algorithms. So we're not starting from scratch. We have a previous experience in our groups on similar processors, but now the Sentinels offer the opportunity to go one step ahead due to its high revisit time and the possibility to combine efficiently both radar and optical sensors. So all those prototypes, surface moisture, green amber overlay, and seasonal crop mapping are improvement of existing ones. And in addition, we are testing several proof of concept that we are realizing while the project is ongoing that could be as important as the previous ones. For example, a tillage change product which can be used to detect if tillage is taking place or not, and is well linked with conservative agriculture. Or what we call an added value crop classification, which can be applied regionally if several ancillary information is present and can provide very, very detailed maps for CAP monitoring. Well, the validation strategy, as I say, is based on campaigns that we are carrying on in several sites. So all the variables which are being produced by these processors are being applied over these test areas in Spain, France, Italy, and Poland, and also outside Europe in several sites we have similar conditions, at least similar type of crops. Well, as I say, we intend to provide Copernicus with products that are not still available, although they are feasible. I mean, we are not inventing anything very, very new, but Copernicus offers the possibility to develop these prototypes, especially as you see in these biophysical measurements. They exist already, but at higher spatial resolutions, or lower, I mean, which are not useful for agricultural applications at plot parcel level. And in other cases, for example, a seasonal crop mapping, meaning we are able to produce crop maps during the season, is not existing, and it could be or for example, this tillage change product. So in some cases, what we offer is an increase in the spatial resolution, which allows using these prototypes in agricultural applications. In another case, just a new type of information that was not previously available. I don't know how much time you have. Just 2 minutes? Okay. Okay. Anyway, I try to go fast because this is not the kind of conference for entering maybe in high detail on how the prototypes work. Obviously, we can discuss later if you're interested. But basically, the surface moisture service is mainly based in Sentinel-1 images, and it's a change detection algorithm, which benefits from the short revisit time of Sentinel-1. So the rationale behind this algorithm is that the short-term changes in some crops, not in all crops, could be associated with changes in soil moisture. And the results so far are very, very, very good. This is a map covering one of the test sites, which is the biggest region in Spain, the size of Portugal or Hungary, so quite a big region. And the results so far are, and we have several test areas around here, and the results are very promising so far. This prototype can provide 1 kilometer maps of soil surface moisture, but if parcel data are provided, it can be highly improved, the spatial resolution, because the spatial averaging is done based on this parcel data, and this improves the accuracy of the product. So it can be improved if this parcel data, which it's almost available all throughout Europe nowadays. In the case of leaf area index, as I say, the leaf area index is the area that the leaves project on the ground and gives an idea on how dense is vegetation. The main improvement here is that we are not only providing maps of what is the classical green lie, but also what is called brown lie. So the area projected by a senescent vegetation on the ground, which is quite important for monitoring the status of crops, and also very important, especially in dry areas, Mediterranean areas, where for much of the year the vegetation is not green. So basically, the algorithm is based on Sentinel-2 images, and we can provide maps of both green and brown lie, and then combine them in a composite map with always with an estimation of the uncertainty. Okay, I will go faster. So this is an example of the different trends of green and brown lie. In the case of the seasonal crop maps, which are intended to be a pan-European service, what we're doing is to apply automatic supervised classification methods based on the combination of Sentinel-2 and Sentinel-1 and very limited ground truth. This is the key for a pre-operational product or service. And okay, I will go fast. Unfortunately, I cannot enter into details, but basically here you see how the accuracy is increasing. This is November, and this is okay. This is whole year. So this is how the different maps produce through the season. In this case, this is the crop match, which separates crop and not crop. And in this case, is an example of the maps we're producing, classification maps. And again, you see that the fusion of optical and raw data always provides the best results. And obviously, as you advance through the season with more images, the results are better. In the case of the other mapping approach we're testing, this is a quite different approach which relies on the high availability of parcel data, and the results are much better, and the legend, the level of detail we can achieve is greater. But again, it relies on the regions in which, for example, the CAP farmers' application are available early in the season, so you can use it for training the system. Okay, I will finalize very rapidly with this, which is detects the change in roughness of the soil when it's subject to tillage. And okay, this is a different application for irrigated, not irrigated area, which based on the actual soil phase semester of the irrigated fields in respect with the surrounding areas, can detect where irrigation is actually taking place. And well, we're testing also a crop yield model, but this is quite difficult to summarize. So basically, we are providing, or we are trying to provide, different services which we believe could be very useful in this context of the geospatial intelligence. So thank you very much.
A warm applause for Antonio. He made me feel very young again, because this is the kind of stuff that I used to do when I was younger, and I can already imagine that my colleagues, which have more a lawyer background and so on, they were becoming desperate. But this desperation is not needed, because what Antonio has been showing you is what we have been referring to as the smoking gun or the systemic problems, right? With this, all the algorithms which are being developed here, all these products. We will be able to look at effects of climate change, of, especially in Spain, the effects of water abstraction. And we'll come to water in a second, where we will not be talking about remote sensing anymore. But this type of research, using all these different sources of information. And remember, one of the things that you mentioned, Antonia, where the ELPIS IX data is available, we can achieve much better, higher precision in what we observe from space. And this is something I see my colleagues there from DG Agri laughing, because we've been working hard with them to make it sure that this ELPIS IX data is available for higher quality and precision, also for research, and for the more systemic cases that we will be observing over time. So thank you very much for this, Antonio, and for coming to this session where first you thought, what the hell am I doing here?
Yes, that one.
Now you understand. So I mentioned water before, so now we are going to look at something slightly different. In our compliance assurance action plan, in the guidance on rural areas for compliance, there is a focus on water quantity, water quality. You all understand that this is an issue. So it's my pleasure to introduce the next speaker. It's going to be Dimitra. Ah, there she is. On Diana, a beautiful name for a project, I must say. Detection and Integrated Assessment of Non-Authorized Abstractions using EO.
So, hello, I'm Dimitra Perperidou, and I'm here on behalf of AgroApps. As Hugo mentioned, I'm going to present to you our solution, Diana, which is detection and integrated assessment of non-authorized water abstractions using Earth observation. I think what Hugo mentioned earlier today, that Diana encapsulates the use of spatial data, and it will be a smoking gun for illegal abstractions. So, I know that you all know the problem, but I'm just going to mention a few facts. We know that we don't have enough water in our planet, so let's put it in a scale that you can see here. So if you roll up all the water available on the planet, you will have just a ping pong ball. 97% of that water, though, is salt water, which means that we cannot use it to irrigate our plants or to drink it. So that leaves us just with 3% of fresh water. And from that water, 99% is frozen. So again, we cannot use that water. What we have in the end is just 1% that we can use, which in that scale is just as big as a seed. 8% of the available water is used in urban uses, 22% in industrial uses, and we have an extraordinary 70% that is used in agriculture. A quarter of the 182 billion cubic meters of water that is extracted in Europe every year is used in agriculture. It's a very common practice in irrigation is a very common practice, and we use it to stabilize our crops, to reduce risks, and to increase our yields. Irrigation is a major cause of non-authorized water abstraction or over-abstraction, which means that we are using more water than is permitted or that is available. If we put on top of that scarcity of water resources and droughts, the problem only intensifies. For example, between 2006 and 2010, we had droughts as a recurrent phenomenon in Europe that affected 15% of the European territory and 17% of the population. So the problem only intensifies. We also have field inspections that can help in identifying and monitoring water abstractions, but they are both time-consuming and costly. Just take into consideration that we need to spend almost €8 for every hectare that we are inspecting. So the need for solutions is more than obvious, and here is where Diana comes in. Diana will empower water authorities and managers to optimize their identification process And also it will help them improve their plans and practices in extreme conditions such as drought. So the Diana is a commercial platform that provides 3 services, which is a non-authorized water abstraction, as you can see, and monitoring, drought monitoring and forecasting, and the support of the monitoring of the Water Framework Directive. So I don't have a technical background, so I'm just going to say a few things here, which is the process that we're using in a nutshell. We have a lot of partners and we have the know-how to implement water abstractions. But what you see here is a diagram of the process that Diana is using to detect water abstractions. We are acquiring Earth observation images and combining them with other data to provide maps that depict the irrigated areas. So we enable the users to see which agricultural areas in their jurisdiction have been irrigated. And we combine those with data that they provide themselves into the system in order to cross-check. So in the end, the user can see which of those areas were supposed to be irrigated or not and detect water abstractions or over-abstractions. I need to mention here the data sets that we are using. I think it's important within the Inspire presentation to do so. So we're using Sentinel-1, 2, and 3, Landsat, and MODIS, and we combine them with meteorological and other data in order to increase the spatial and temporal accuracy of our services. Here you can see again the pre-processing and the products that we are producing from Earth observation, and of course other data that we're using to combine them with. And here you can see a first version of the platform. As you will be able to see, it's separated into 3 different tabs. In the first one, you can see the water abstraction and all the information that the users told us that they will be actually useful for them in order to make important decisions. So we have the total of irrigated and non-irrigated areas and the volume accumulated throughout the year, the volume of the water accumulated throughout the year, as well as the crop types of the area, and of course the month in which we had the peak in the water use. And here you can see at the same tab some diagrams about the monthly average crop aggregation and the evolution of the accumulated volumes of water. And of course, in the end of the page, we're providing users with a map where they can see the irrigated areas, the gross irrigation requirements, crop classification, and all the parameters that are necessary for them to make all the important decisions. As I mentioned before, an important parameter of illegal abstractions and of the support of the Water Framework Directive in general is drought, which is a recurring phenomenon. So we provide a 6-month forecast of drought. You can only see some of the indices that we have included in the first version, which are going to be increased as we go. And here are the information that we are taking for the support of the Water Framework Directive. So we have all the information from the first service that the authorities need in order to support the implementation of the Water Framework Directive. We are currently validating the platform and the services. So we have 3 pilot sites in Spain, Italy, and Romania. We believe that in 2019 we will have the first data available. And I would like just to take a moment to say that spatial data and services are the basis for environmental policies, and in the case of Diana, they are helping in supporting the Water Framework Directive, Directive 2000, as you can see, and we promote sustainable water use and enhance protection and improvement of the aquatic environment, and of course, we're contributing to mitigating the effects of floods and droughts. As I mentioned earlier, I'm here on behalf of AgriOps. Of course, Diana is a service, is a solution that we are doing with many partners across Europe. AgriOps specifically is doing EO-specific applications, climate services, and custom solutions. And our next steps is we're actually going to use spatial data for agricultural insurance. And thank you for your attention.
Thank you, Dimitra, both Diana and Dimitra. This was a beautiful presentation, wasn't it? I mean, it connected all the dots. We had the users, the duty holders, support to them, inspections, long-term trends, excellent use of Earth observation combined with other sources. Another excellent example for one of the pressing. I hope that my colleagues from that are leading on the compliance assurance are also convinced that geospatial intelligence is going to be a concrete contribution to this action plan. So thank you very much for this. Now time is running, time is pressing us actually. And to continue on the field of water, right, I have the pleasure to announce a compatriot of mine from an organization that I know very well and admire a lot, the Vito. And they do running a project called WaterProtect, innovative tools for drinking water protection in rural and urban environments. Maybe a little bit less remote sensing, a little bit less Earth observation, but extremely relevant in terms of technology and application domain.
So this is a picture of the kickoff meeting that we had in June last year. So this project is now, let's say 1 year up and running. And it aims at protecting water sources in drinking water abstraction areas. And I'm going to present some highlights of it related to the use of GeoICT in this context. So the driver behind this project is that we still face a continuing problem of nutrients and pesticides in surface and groundwaters across Europe, and we seem not to be able to bend this trend. And so we are looking for solutions to this problem. And the aim of WaterProtect is, what we observe is that mitigation measures to really overcome these water quality problems, they're either not in place. If they're in place, they might be not effective. And if they're, at least it's often, many occasions, they just don't get implemented. So with this project, we want to overcome this. We really want to contribute to the effective uptake and realization of management practices and mitigation measures to protect the drinking water sources. Because there is already a lot of knowledge around on what does an actual buffer strip do at the field scale. But we see that there are some barriers that prevent those measures to be implemented. So our methodology is really about action research. It's bringing our research close to the actors in a multi-actor setting. This was somewhat required by the Commission to do so, but it is really a powerful instrument because you rethink your research in terms of how you go to the users, to the local actors, and how you step with your research and your tools within these local actor communities. And so we defined at the local scale, local action labs in which we collaborate with farmers advisory, with stakeholders, environment agencies, drinking water companies, abstracting water, because they all need to come up with a solution for these water quality problems. And so there are a number of themes along which this project works, like new governance strategies, financing. How are we going to finance these mitigation measures? You can do it from a purely regulatory perspective, but you can also be creative if you can create value by improving the water quality. So we are discussing about that. That's about governance. How do we govern this process? It's about sharing data. It's about creating transparency of the data within these communities to make trust, to build trust among the actors that we have in the project. And also to convince the actors, the farmers, that the management practice really pays off in the end for them too. So it's not only talking about there are a number of best management practices, it's about how can you bring that in your setting into practice. And then finally, what we think is a very powerful, or could be a very powerful instrument in creating transparency and trust among the local actors to do something about the water quality is to use tools, IT tools that visualize in a very clear way the management and the impact that this management has on the water quality. So this is a bit the logic of the project, is that we create transparency on the biophysical system of a water catchment. That's the upper part of the slide. So that's creating knowledge, information, and you know that landscape information can be generated by remote sensing, but also by other means. Governance, so put a lot of energy in how to create a good forum to really change the practices of the farmers. And then we combine this information and we bring that together. And it's already been highlighted in this session. It's about bringing together information from ground sources, water quality information, landscape information, and connectivity between the parcels and the water. So that is what we envision in the what we call collaborative tools. So the tools are an instrument to create the collaboration and to create the transparency within that system. And then we believe that we will increase the success rate of implementation of the measures because we co-construct this together with the actors in the system. So we see already signs in the project that this increases the engagement of the local actors by doing things together and to go for a common solution. Important there is participatory monitoring. It's not like a regulatory instance is only monitoring. It's setting up the monitoring together with the actors so that they believe the results and they trust the results. It's about discussing about which kind of management practices are there, which are the right ones at the right place based on our system knowledge. And it's about creating an environment in which we can visualize this and discuss about it, because a farmer will be connected to the topic if he sees his own parcels and he can see the effect of his behavior. So we are building tools, and this is an example of the WaterProtect tool that we apply in Belgium, Romania, Italy, and Ireland. So what you see is that the user gets immediately a map. He can visualize the catchment areas and the drainage areas. He can visualize the rivers, where the monitoring is, because that was striking to us the first time we went out to the farmers and we said, do you know about the water quality problems here in your area? And they said, no, they're even not aware. So you should bring the data also very close to the actors. Bringing like maps coming from remote sensing, abstracted from remote sensing, but also from local inventory studies, of course. So agricultural use, what crops are grown, erosion sensitivity, because in terms of nutrients and pesticides, erosion is an important contributor. So you can already highlight some areas in which you can maybe target your mitigation measures. These are already planned measures by the government. You can zoom in into the system. And you can then further give information on the water quality, time series of the water quality, monthly averages as compared to regulatory standards, so that they can see in one glance how their water quality exceeds the standards or is below the standards. What kind of land use is associated to an outlet of a catchment, in which you can then visualize what kind of crops are contributing to this water quality, or what kind of erosion sensitivity you have. We are further improving this in iterations with farmers, with local users, because we are in continuous interaction, and we are now improving the user experience of this tool, because we found out that we can still improve that in dashboarding. So these are the impacts that we want to create apart from the others. We want to have a lot of users using our tool, of course, but we are now testing it in the different action labs, and we are confident that we will reach the amount of users using these kind of tools. These are the local action labs. Management is within Vito, and then on multi-actor management, this is with Ilvo. You can find us on Twitter and on the internet. Thank you.
Well, ladies and gentlemen, that concludes this first session. We have another session where we will continue around this topic, but what you have noticed in Pete's presentation again is the complementarity of all the different activities which are ongoing. Pete was concentrating this project on water quality. Before we were looking more at water quantity, right? You have seen something which is very close to our heart, of our activities, of our unit, the compliance unit. You need to inform people about the degree of compliance that is being met around them. They may not be aware that there is a problem. There is a compliance issue. I'm convinced myself personally, most of the problems that we have are happening because people simply don't know that they are responsible or partially responsible for a problem which is creating issues for others, for the environment and so on. So we need to inform them. We need to involve them with us. That's good governance, and that's, again, part of the core activities of our directorate and of our DG, is building up this governance, this collaboration with the duty holders, with the inspectors. So it's, again, it's teamwork. Now, we have covered in this session quite a variety of topics, from the CAP, from the subsidies, from the livelihood of farmers, how we can help them. We have crossed over into other areas, more scientific, looking at long systemic changes, new algorithms, new tools that could become relevant for this. We have been talking about water quality, about water quantity. One thing that is striking is that we need to bring together all these different types of data, right? We have not been discussing about the obstacles that these projects have faced to bring it together. Because sometimes the projects may work because they have established a good partnership within the project. They have the data, it comes from somewhere. In other cases, if you now want to port it to another area, you may suddenly encounter obstacles of data not being available, of not accessible. LPIS, IX was mentioned, or others. And this is something that systemically we have to address through, for example, the INSPIRE directive, so that these excellent good practices and results can actually spread out and become adapted to local issues and problems as well. Now, I know I'm eating into your coffee break, but there will be another session, but still, I would not deprive you of the possibility to ask a few questions to any of our excellent presenters, or even to myself, or to the Commission. We have colleagues here. Aurel is there. Liam, the spiritual father of the Environmental Compliance Assessment Framework, is here as well. So please, shoot if you have questions or observations. Yes, please. I am going to rush over. No, thank you. The microphone is being brought to you.
Thank you. Gabriele from Austria. I have a question. My point of view is the water point of view, and the water and quality and quantity as well. We are looking for the data for irrigation data. So my question is it possible using the satellite data to know or to estimate the amount of water used by irrigation, so that we can use this data to see if in a certain area, for example, the groundwater body might be at risk in the direction of that the quantity is going down or is depleting.
Okay, thank you for this. Luckily, we have lots of experts around us. I remember from my previous work that we were monitoring the levels in water reservoirs from space, for example, using light. But there may be others. Anybody of our experts of our projects that can provide an answer to this question? Can help me, so to say, or somebody else from the audience? It's not a workshop, but I like a little bit of interaction, so please do.
Yeah, I'm Milad Mahur, PhD student at the University of Twente. I believe we have very good public remote sensing data, and with the measure of the evapotranspiration, you can measure the irrigated, agricultural irrigated area per cube meter per day really easily. That's my answer to you.
Well, thank you for that. I'm sure there are going to be other answers, and we're not going to be precise. But one thing that I learned from
yes,
this...
my name is Carlo De Michele. I'm from Aerospace, which is partner in Indiana project. I confirm that it's possible now to evaluate the crop water requirements. Of course, we don't see if when the farmer go in the field to irrigate, but it's possible to estimate the crop water requirement with a good accuracy is that what we have already done in Indiana project in several pilots, also to estimate crop water requirement and also irrigated area. The real story behind Fatima is because a lot of water user associations ask for irrigated area data, because the money which farmer pay to water user association is based on irrigated surface. So it's possible now to detect the irrigated area and also to evaluate the crop water requirements of the crop. Based on that, if we have data from the groundwater, it's possible to estimate a water balance about all the basin. It's what happened in Spain, for example. And they use this kind of technologies from, I think, from 20 years. This is my experience.
Maybe just as first proxy, maybe.
Could you please say who you are?
I am Aleida Mohamed from DG Agri, but I will make some publicity for a tool which is not from DG Agri, but Mars Unit in GRC. They have a very nice viewer online since 10 years now, and you can, with a resolution of 25 by 25 kilometers, see where irrigation probably is needed or not, depending on the water requirements for a specific crop. They can be easily seen on the web. You have just to register.
Great. Now, we are at the end of our session. I'm happy with these questions, and actually, please talk to the people here, right? If you have other questions, there will be a lot of follow-up of these sessions in terms of user requirements, about working together. So this is not the end of the story of you being here. Now, in the short term, we have the coffee break, then we continue with our session. Tomorrow, there will be the very interesting final workshops, so to say, of the recap project in the afternoon, followed by another workshop on, I'm looking at Jan Dirk there, Agriculture and Inspire, right? We are all welcome to participate in that workshop, right, Dirk? It's true. So I'm not telling you any lies, and there's no lie in me saying you can all go for a coffee break. Well deserved. Thank you.